Welcome to today's presentation on the dependent variable in experimental design. This session is for those aspiring to delve into the intricacies of experimental design within business research. Let's dive in together as we explore the pivotal role of the dependent variable and strategies to ensure construct validity in the context of business studies.
By the end of this presentation, you will gain a comprehensive understanding of the experimental design's cornerstone, the dependent variable. You will appreciate its pivotal role in shaping research outcomes and generating meaningful insights within the experimental framework. Additionally, you will grasp the paramount importance of construct validity in the realm of research, comprehending its significance in ensuring that measurement tools accurately capture the intended theoretical constructs. Moreover, you will be equipped to identify and navigate challenges inherent in measuring constructs, particularly in the context of business studies. Finally, the session will empower you, as researchers in business academia, with practical strategies to enhance construct validity specifically in the domain of the dependent variable, fostering a holistic approach to rigorous and reliable research practices in business academia. In delving into the introduction of the dependent variable, DV, you will acquire a comprehensive understanding of its integral role within the framework of experimental design. The DV, often referred to as the observed outcome, stands as a cornerstone in experimental studies, serving as the primary metric through which researchers assess the impact of variations in the independent variable. This relationship directly aligns with the overarching aim of experimental design, to systematically explore and analyze cause-and-effect relationships. Throughout the lecture, you will be exposed to tangible examples of DVs in business research, ranging from employee productivity and consumer purchasing behavior to financial performance. These examples not only illustrate the versatility of the DV in capturing diverse phenomena but also underscore its relevance in evaluating the success and implications of various interventions within the business context. A specific focus will be directed towards the significance of precise measurement, with an emphasis on construct validity. Construct validity becomes paramount in ensuring that the measurement of the dependent variable accurately reflects the intended theoretical construct, contributing to the overall validity and reliability of research outcomes. The meticulous consideration of measurement intricacies aligns with the broader objective of instilling rigorous and robust research practices within the domain of business academia. The role of the dependent variable within the context of experimental design is multifaceted and pivotal in shaping our understanding of causal relationships and experimental outcomes. At its core, the DV acts as a sensitive and responsive indicator, capturing the nuanced impact resulting from intentional changes in the independent variable. This responsive nature makes the DV a focal point for researchers seeking to gauge and measure the outcomes of experimental manipulations. In the intricate web of experimental research, the DV is not just a passive responder, it forms a direct and explicit connection to the research hypotheses. Variations observed in the DV are not mere fluctuations but rather the manifestations of the changes researchers seek to elucidate, comprehend, or predict. Therefore, the DV becomes a dynamic entity, embodying the very variables under investigation and providing a tangible expression of the experiment's effects. As researchers navigate the complexities of experimental data, the DV emerges as more than just a measurement, it becomes the foundation upon which conclusions are built. The observed variations in the DV become the bedrock of researchers' assertions, enabling them to make informed and evidence-based statements about the effects brought about by the independent variable. This evidential weight underscores the significance of the DV in the process of deriving meaningful insights from experimental studies. Beyond its role as an indicator and a foundation, the DV also takes on the guise of a quantifiable metric. This quantitative nature empowers researchers with the ability to not only measure but to rigorously analyze and compare outcomes across various experimental conditions. The precision afforded by the quantifiability of the DV enhances the robustness and reliability of the experimental findings, contributing to the overall credibility of the research outcomes. Moreover, the DV is central to the very essence of experimental design, cause-and-effect inference. By meticulously measuring changes in the DV, researchers can confidently attribute observed effects to the intentional manipulation of the independent variable. This causal linkage established through the DV allows for the drawing of significant and substantiated conclusions, elevating the experimental process beyond mere observation to a realm where causal relationships are uncovered and understood. In essence, the role of the dependent variable is intricate and profound, encompassing its dynamic responsiveness, its foundational role in hypotheses, its status as a quantifiable metric, and its central role in establishing cause and effect relationships. It is through a nuanced appreciation of the DV's multifaceted role that researchers can unlock the full potential of experimental design in advancing our understanding of phenomena in the realm of business research and academia. Navigating the measurement of the DV comes with its set of challenges that demand careful consideration in experimental design. One notable challenge is the inherent subjectivity and potential for varied interpretations, especially when dealing with human observations or self-reported data. The complexity of defining and operationalizing the DV poses another hurdle, particularly when attempting to capture abstract or intricate constructs. This intricacy underscores the importance of ensuring that the measurement aligns precisely with the intended theoretical construct, a task that requires methodological rigor. Natural variability within the DV, unrelated to experimental manipulations, presents an additional challenge. Distinguishing between genuine effects and random fluctuations in the data demands a meticulous approach to data analysis. Moreover, the temporal dynamics of the DV can introduce complexities, requiring researchers to employ sophisticated measurement techniques to accurately capture the dynamic nature of certain phenomena over time. The sensitivity of the DV to external factors constitutes yet another challenge. External influences or extraneous variables may impact the DV, complicating the isolation of observed effects solely attributable to the independent variable. Addressing these challenges becomes paramount in ensuring the validity and reliability of experimental findings, prompting researchers to employ robust methodologies and analytical strategies in their pursuit of accurate and meaningful measurements of the DV. By acknowledging and proactively addressing these challenges, researchers can enhance the overall quality and credibility of their experimental designs in the realm of business research. Construct validity, particularly concerning the DV, is fundamental to ensuring the meaningfulness and accuracy of experimental measurements. This facet of validity delves into whether the measurement method effectively aligns with the intended theoretical construct that the DV seeks to represent. It scrutinizes the measurement's ability to comprehensively capture the full spectrum and intricacies associated with the DV, ensuring that it goes beyond a surface-level representation. In the realm of the DV, construct validity encompasses both convergent and discriminate validity. Convergent validity assesses how strongly the DV measurement correlates with other measures of the same or similar constructs, reinforcing the measurement's alignment with the overarching theoretical framework. Discriminate validity ensures that the DV measurement doesn't correlate strongly with measures of unrelated constructs, affirming the specificity of the measurement to the intended DV. Predictive validity is another dimension of construct validity crucial in the context of the DV. It scrutinizes the measurement tool's ability to predict future behaviors or outcomes associated with the DV, providing valuable insights into the practical significance of the DV measurement. This predictive dimension adds depth to the construct validity assessment, offering a forward-looking perspective on the reliability and applicability of the DV measurement. Furthermore, construct validity for the DV extends beyond a singular context, evaluating whether the measurement remains consistent and relevant across various conditions and settings. This consideration ensures that the DV measurement is robust and applicable in diverse research scenarios, enhancing the generalizability of experimental findings. Convergent validity, a pivotal aspect of measurement validation, holds particular significance in the context of the DV. This form of validity assesses the extent to which different measurement methods, theoretically linked to the same construct, yield consistent and positively correlated results. In essence, convergent validity for the DV ensures that various approaches employed to measure this variable align in capturing the intended construct. To establish convergent validity for the DV, researchers adopt a multi-method approach, utilizing diverse tools or sources to measure the same construct. The consistency in results obtained from these varied measurement approaches serves as a key indicator of convergent validity. Comparisons with existing measures or established methods within the field also play a crucial role. Positive correlations between the DV measurement and established tools bolster the evidence for convergent validity, affirming that different ways of measuring the DV converge in their assessment. Statistical analyses, such as correlation coefficients, are commonly employed to quantitatively assess convergent validity for the DV. Calculating these coefficients between different measurements of the DV provides a numerical evaluation of the degree of convergence, offering researchers a robust tool to ascertain the consistency and reliability of their measurements. Let's consider an example from HR management research where we're investigating employee engagement, a commonly studied construct. In this scenario, let's say we're interested in measuring employee engagement using two different survey instruments. To establish convergent validity, we would administer our primary survey designed to measure employee engagement and another well-established survey known for effectively capturing the same construct. Both surveys should theoretically measure the same underlying concept, employee engagement. Suppose our primary survey asks questions about job satisfaction, commitment to the organization, and enthusiasm for work. To establish convergent validity, we might also administer a widely recognized employee engagement survey, renowned for capturing similar aspects of the employee experience. If the responses from our survey strongly correlate with the established survey, it indicates convergent validity. This alignment reinforces that our survey is indeed measuring the intended construct of employee engagement. Meanwhile, discriminate validity, a crucial facet of measurement validation, holds particular significance in the context of the DV. This form of validity is concerned with ensuring that the measurement of the DV remains distinct from measures of unrelated constructs. In essence, discriminate validity for the DV establishes that the measurement is specific to the intended construct and is not unduly influenced or confounded by variables that are theoretically unrelated. To ascertain discriminate validity for the DV, researchers adopt a strategic approach, utilizing diverse measurement tools to assess constructs that should theoretically exhibit weak or no correlation with the DV. The absence of strong correlations between the DV and measures of unrelated constructs serves as a key indicator of discriminate validity. Statistical techniques, including correlation analysis, play a central role in this evaluation, allowing researchers to quantitatively assess the degree of discrimination between the DV and unrelated variables. Cross-validation with established measures within the field further reinforces the evidence for discriminate validity for the DV. Comparisons with tools measuring constructs unrelated to the DV provide additional assurance that the measurement remains specific to the intended construct. Sticking with our previous example from research in HR management, now let's consider discriminate validity. In this context, we want to ensure that our survey measuring employee engagement does not strongly correlate with surveys measuring unrelated constructs, preventing potential confusion or overlap. To establish discriminate validity, we might administer surveys measuring constructs unrelated to employee engagement, such as measuring stress levels or perceptions of the office environment. If our survey measuring employee engagement shows weak correlations with these unrelated surveys, it affirms discriminate validity. This ensures that our survey is specific to the construct of employee engagement and is not inadvertently measuring aspects unrelated to our research focus. In the realm of HR management research, ensuring the contextual relevance of our measurement tools is paramount. The intricacies of employee engagement can vary widely based on organizational cultures, industry nuances, and the specific challenges faced by employees. Therefore, when selecting measures for our dependent variable, which in this case is employee engagement, it is crucial to align these measures with the specificities of the organizational context. By doing so, we enhance the applicability and meaningfulness of our findings. Contextually relevant measures not only resonate more deeply with the experiences of employees in a particular setting but also contribute to the generalizability of our research insights within the dynamic landscape of HR management. Further, mitigating measurement bias is a critical consideration when delving into HR management research, especially when exploring constructs like employee engagement. Bias in measurement tools can stem from various sources, including wording of survey questions, cultural nuances, or inherent biases in the tool design. To ensure the robustness of our findings, it is imperative to be acutely aware of potential biases in our chosen measurement tools. Additionally, researchers should proactively employ strategies to minimize or control these biases. This vigilant approach not only fosters a more nuanced and objective interpretation of employee engagement but also contributes to the overall credibility and integrity of our research outcomes in the realm of HR management. In navigating the complexities of experimental design, several practical considerations emerge when it comes to the measurement of the dependent variable. First and foremost is the emphasis on measurement precision. It is crucial to select measurement tools for the DV that not only capture the intricacies of the construct but also ensure reliability and validity. The choice of precise and accurate measurement methods enhances the overall quality of data collected in the experimental study. Contextual relevance stands as another pivotal consideration. Researchers must carefully evaluate and choose measures for the DV that align with the specificities of the research context, industry, or population under investigation. This contextual alignment ensures that the chosen measures are not only valid but also applicable and meaningful within the particular setting. Mitigating measurement bias is a perpetual concern when working with the DV. Students should be encouraged to critically assess potential biases in their chosen measurement tools and methods. Moreover, they should explore strategies to minimize or control these biases, fostering a more nuanced and objective interpretation of the DV. Longitudinal considerations come into play when dealing with the DV. Researchers must recognize that the DV may exhibit changes over time. Hence, the selection of measurement tools and approaches should be attuned to capture this dynamic nature. Incorporating longitudinal perspectives ensures a more comprehensive understanding of how the DV evolves throughout the course of the study. Lastly, ethical considerations should be at the forefront of students' minds. As they select measures for the DV, a thoughtful approach is necessary to ensure ethical soundness, respect for participants, and alignment with principles of responsible research. By integrating these practical considerations, students can approach the measurement of the dependent variable with a strategic and conscientious mindset, contributing to the overall success and integrity of their experimental designs. Wrapping up our discussion on the dependent variable in experimental design, it's clear that precise measurement is essential for drawing meaningful conclusions. As future business researchers, approaching the DV requires an awareness of theoretical constructs, an understanding of measurement complexities, and strategic decision-making. The practical considerations discussed, from ensuring precision to addressing biases, provide a comprehensive guide for responsible research. Remember, the DV is more than a variable, it encapsulates the essence of our inquiries. By integrating these insights, we pave the way for impactful and thoughtful contributions to the field of business academia.